Welcome to Gunship.
So, it's just reflecting my screen. Yeah, it's fine. So, it's between, I'm standing in the way of lunch, so I will try and be prompt. If by some miracle you haven't heard of the Go language, get your device out and have a look at golang.org, or just a bit of what's going on in the world out there, and discover what Go is, just to save me some time. This is mildly batty, this project. It's about taking the Go language, translating it into Haxe, and then using that translated Haxe within your own Haxe programs. Or if you're a Go programmer, you can create what you want to create in Go and generate the Haxe. This is me talking last year. I tried to wear the same clothes, just so I wouldn't confuse anybody. So I want to talk about a number of things. First of all, then a little bit about the transpiler itself. Then I'll give you some examples. Very simple maths example. Slightly more complicated Unicode example. And then a bit of image manipulation. And finally, I'll, hopes and dreams and why we're here sort of stuff. So, if you compare Go and Haxe, if I was at a Go conference now, there would possibly be 5 times more people here. If you look at the active repositories in Go, there are 22,000 odd. So, whereas for Haxe around 1,000. Now, that just simply means there's a lot more code being written in Go. And the good news for you, and the reason why you might be interested in my talk, is that you should be able to have access to some of that code, to reuse those libraries. That's my intention. So if you saw me last year, this is a bit of Go code. You can see the code in the middle there. Each of these gophers is a Go routine, and it's running that code in the middle there, which is Go code. And it's doing it all in a sort of simultaneous way, which is a Go way to do things. Using a Go routine, each of those gophers is running the same Go routine, and the Go routine code is the code you can see there. Just to give you a bit of background. This is exactly what I showed last year. What the hell am I doing standing here? Why have I come back? Well, the reason is, first of all, it's quite a lot faster now than it was, because the code generation's improved. And secondly, one of the things that Go has is a huge test suite. And I've been battling through the year to get the great bulk of that test suite to actually pass in Haxe. Which means that it's pretty reliable, because the Go tests are very, very full. Okay, so here's a little example. This is a Go program. It's possibly the least exciting Go program you're ever going to see, because it doesn't actually do anything. All it does is pull in a couple of libraries, and then on line 8, a little bit of magic inside TARDIS Go to say don't do dead code elimination on these libraries so that they pass through. And then we need to have func main, because Go says you always have to have func main. When you generate this into Haxe, it generates 266 files of Haxe and around 71.4K lines of code. So it's quite a lot of code generated. Then inside your actual Haxe program, the maths library in Go is very big. It's got all sorts of things I don't even understand in it. So I picked an example of something I did understand. Which is find the next floating point number, in this example, the next floating point number after 2 before you get to 3, and the next floating point number after 2 before you get to 1. And I thought, yeah, that'll be enough. I'll do that as an example. But then when I did the example, and I made this to show you all, I found that in C++ and C#, actually what the standard float conversion does is round those results up to 2. So I then had to go and pull in another library, the string conversion library, to make sure that it actually gave the right result. If I just, whoa. I'll just show you that. So just to be clear what's going on here, we've got, in this little example, 2 little files, one Haxe, one Go. We just run TARDIS Go to create the list, to create the TARDIS code. The TARDIS code is quite a lot of it. It was just demonstrated, just created on the fly there. And then, I shan't do this every time, don't worry guys. You can just go and run the interpreter, just to prove that you get the right result. Okay? So let's go on to a slightly more complicated example. This is using something that isn't inside the Go standard library, it's actually inside an additional library. The people who wrote the Go language actually also wrote the Unicode UTF-8 specification, so they're very much into Unicode normalisation. Anyone here know? Anyone know what I'm talking about with Unicode? Well, thank you. Some of you do. Okay. This is much bigger. It generates, as you can see, it generates lots more files on the bottom there and lots more lines of code. So I won't be doing this live. And essentially, it allows you to compare 2 strings which are encoded in different ways, but when you print them, look the same. So in this example, just the list of strings at the top there and the results you get on the right in the comment. So function compare, all it's doing is creating a Go type, then telling it to be NFKD normal form, which I don't completely understand, but apparently that's one of the 4 options there are. Taking each of the strings and putting them into that form and then comparing them. If I just go and run this, you'll get, just to prove you do get the result. Cool. And what I really like about this, so you've got the normal stuff there. I don't know if you can see it. Do I need to make it a bit bigger, perhaps? What I particularly like about this example is it's got some Japanese at the bottom, and I'm all in favour of Japanese. Okay. So finally, we've got a wonderful Go Nude library, which does an analysis to see if an image appears to be nude or not. Which written by a crazy Japanese guy. Fine. For this one, I had to do something slightly odd because it uses a disk. It actually uses a file rather than passing it in just as a byte string or something. So that's why IOUtil is also in there. IOUtil, just to load the file. And inside the TARDIS Go runtime environment, there is a file system, an in-memory file system, so you can do all of this file access. As you can see, this creates even more Haxe files and even more lines of code, so it's big. Essentially, though, all it does is pick up the file, write it in function write file. All it's doing is writing the file into a bit of disk, and then just running the execution, the is nude at the bottom to see if it's nude. So let's give it a try. One of the issues I have, is it doesn't handle large files well. So the first thing I did was put a large file in there. It takes a little while to run, it works. So this is my daughter and somebody else's baby, sadly not my grandchild, just to prove that this image looks fine. And it does work on large images, just takes a little while. So I'm going to choose some other examples. First of all, let's just try a lady in a swimsuit. Yeah, she's all right. And then we'll try some with showing a lot of flesh, maybe. Yeah, she's all right too. Now you're waiting for the big one, aren't you? Well, Rubens obviously had the right idea about how women should look. Rubens does do nudes. And someone else who I've got a nice little image of is, you'd think this one would be nude, wouldn't you? But no. And finally, let's go for Dieter von Teese, who does look nude. So it seems to be all about girl bits. Right. Back to the boring stuff. So just to finish off, there's a bit more work to do to make it really usable. Code size is still larger than I'd like. It doesn't run as fast as I like. I run benchmarks against Go, and because Go runs very quick, this runs very slow. So I've got some work to do to speed it up. And the call interface, as you've seen, is a bit ropey. It doesn't look too nice at the moment. So I'd like some, stop me over the course of the next couple of days and tell me how it should be better. That would be really nice. I'd like to get it integrated into the Haxe ecosystem somehow, but again, I need some advice on how to do that. And what I'd really like, I'd like to be standing here in a year's time saying, the great bulk of the Go libraries that are out there, you can pull into Haxe and use. Okay?
Hey, great work. Did you try to run the output of TARDIS Go compiler with a new analyzer in 3.2 to see if it reduces the generated code in the end?
My experience with the analyzer is it works on JavaScript. On other targets, it doesn't always work. Is my
it breaks your code, you mean?
Sorry?
So it breaks the code, you mean? It's like it breaks the runtime, or it doesn't reduce the output?
I mean, it sometimes on C++, for example, my experience is it doesn't always produce a result that actually works, even.
Well, we have some.
On JavaScript, for small examples, it works wonderfully. When it works, it's wonderful. But on larger examples where there's some quite complex code in here, and it gets a bit lost.
It's still an issue. If you can manage to reproduce such bugs, then you kind of find the function that breaks when it's analyzed.
Yeah, we could certainly
then we will fix that. Then.
Yeah, I've done, in order to, I mean, one of the things that I've done, obviously, in order to get the Go test suite to work, I've had to write a layer between what the Go uses and what Haxe does, and there's scope for me to talk to you in detail about where there are some gaps in making it consistent across the, across the suite. Yeah.
So as I understand it, Go's kind of shtick is all about multi-threading and parallelism and stuff like that. And I'm kind of a loser, and I've almost never used Hex for much multi-threading or anything like that. But I know it has those capabilities. I was wondering if you could talk a little bit about the differences in multi-threading and parallelism between Go and Hex, and how this takes advantage of that, or what it does about it.
I wish I could. At the moment, this is written entirely with one CPU in mind. Now, I'd like to dress that up as an advantage, because if you're using this software within your own Haxe environment, you don't want it perhaps to go off and create 101 threads. So it may be an advantage that it's single-threaded, but I'd love to be able to put it into a multi-threaded environment, and I'm looking forward to what Todd's going to say later on.
Do you think that would be a way to address some of the performance issues you were talking about?
No, actually. I think the performance issues are around, the biggest issue that I have is with pointers, because Go has pointers. And I have to simulate pointers inside Haxe, and getting that fast enough is the central issue for me, I think.
Sorry, I missed your talk last year, and you might have covered this then. But what's the actual transpiler written in? Is it written in Hex or
in Go?
In Go. Okay.
Yeah, Go is, they're very kind. They give the first 2/3 or more of the compiler is all written in Go, and so you can get out of it an SSA form if you're into compilers, single static assignment form. And what I do is I pick up that single static assignment form and translate that into Haxe. So all the front end of the compiler is a Go compiler, just like a Go compiler. You know, it is a Go compiler. Just I didn't have to write it. Yay! Okay. Very much. Thank you.
Welcome to Gunship.